In chapter 9, the variable will be in the exponent for the first time in your math career. Okay, and by the end of the chapter, we will be able to answer the question, for example, 3 to what power is 5? Okay, you don't know how to answer that right now. You could answer 3 to what power is 9, but you have no way using your current math skills to answer 3 to what power is 5. Right, we're going to learn how to do that using exponential equations and logarithms. So why did the 2x is an example of an exponential equation? Here are a couple other examples. Y equals 1/2 to the x power. I'm just changing the base. In these, you can also have a coefficient. So y equals 3 times 4 to the x is an example of an exponential equation. That first number could also be negative. Y equals -4 times 2 to the x. The number that is the base of the x, though, will always be positive. All right. The standard form. Well, first of all, there are two types of exponential equations: growth equations and decay equations. We're going to talk about both. The standard form of an exponential equation is circled up there. Y equals a times b to the x. I don't think I have that on the wall anywhere, so you'll have to know that. Y equals a times b to the x. A is the coefficient. B is the base of the exponent. A times b to the x. First skill we have to learn is we have to be able to look at an exponential equation and tell whether it's a growth equation or a decay equation. And to do that, you look at B. It is a growth equation if B is bigger than 1. That means it is a growth equation. And I'll be giving you several examples as we go of different types of growth equations and decay equations and real-life examples and all that stuff. It is a decay equation if B is between 0 and 1. Because I told you it's not going to be negative. B, which I've underlined those numbers in pink up there, the B, a times b to the x. If that number is bigger than 1, it is growth. If that number is a fraction less than 1, then it is decay. All right? So the first one up there, y equals, and I added the 1s there to show you that we do have leading coefficients there that are understood to be 1s. Y equals 1 times 2 to the x. That is a growth equation. Y equals 1 times 1/2 to the x. That would be decay, because the base of the x exponent is less than 1. Y equals 3 times 4 to the x would be growth, and y equals -4 times 2 to the x would be growth. Is everybody seeing what I'm doing? Nice, easy topic to ease us back in to the math. Ma'am? All right, so now what I'm going to do is I'm going to show you these two graphs, show you how to graph them, which you already kind of know how to graph them. I'm going to show you the difference between a growth and a decay equation. The pieces that we're going to have to label when we're done are domain and range, something called an asymptote, which I'll show you what that means, and the y-intercept. Those are the features of the graph that we're going to label after we have the graph. Domain, range, y-intercept, and the asymptote, which will be something that we talk about for the next 2 chapters, the asymptote of a graph. Easy concept. Don't panic. To graph these, we're going to make an xy table. So first I'm going to start with y equals 2 to the x. Everybody knows how to make an XY table. We're going to make up our x's. So I'm just going to start, I usually do it so the 0 is in the middle of my x's. So I'll go -3 to 3 with 0 in the middle. But you can do whatever you want. And I'm going to go 2 to that power. 2 to the -3, 2 to the -2, 2 to the -1. If it's a fraction, you can either write it as a fraction or decimal, whatever makes you happy. Doesn't matter to me. And I'm going to write those values in the y column. 2 to the -3, for those of you that are doing these, should be 0.125 or 1/8. Okay. The other values, 2 to the -2 is 0.25, 2 to the -1 is 0.5, on and on and on. 2 to the x power. Just making an XY table, which is a old skill. Usually, though, we were putting the values in on ground level. Now we're putting the values into the exponent, which is different. Plotting those, there is -3.125. I have a teeny tiny blue dot on my XY axis there. -2.25, -1.5, 0, 1, which I made a little bit bigger in pink so you could see it. 1, 2, 2, 4, 4, 8. So there's my curve. Couple features of the curve. It gets out of there quick. Once it goes, it goes. It's growth. It is growing exponentially. On the flat side, it is going to get closer and closer to that x-axis, but it never touches it. Never crosses it. It's going to hug that x-axis forever. Every unit, it gets closer and closer, but it never, ever hits it. Okay? Never gets into the negatives. If you keep putting in smaller x's, 2 to the -4, 2 to the -5, 2 to the -20, 2 to the -600, it's never going to be negative. It never dips below the x-axis. It just keeps giving you smaller and smaller decimals out to -infinity. So it never dips below that x-axis. It's just always getting closer to it. That line that it's always getting closer to that I've just put in green is called an asymptote. The asymptote is the line that a graph is converging to. And in this case, you have to state it. So in this case, it's y equals 0, or you could label it as the x-axis in this case. It's the line y equals 0 or the x-axis. The asymptote is the boundary line, really, that is keeping your graph from advancing. It's a guide, it's a convergence line, a limit, whatever you want to call it, whatever helps you understand it. The domain is all real numbers. Because remember, the domain is where does this graph go left to right? And to me, this graph goes from California to New York. There are no limits left and right for this graph. I can put in 2 to the 1 million power. I can put in 2 to the -1 million power. And I'm going to get values. So domain-wise, there are no limits to this graph. So it's all real numbers. Left and right, this graph has no limits. How about vertically for the range? Does this graph have limits? Does it go up and down forever? Does it go down forever? Down to China? No.
No.
Because it doesn't go below the green line. The green line prevents the graph from going down forever. It doesn't go to the bottom of my screen, for crying out loud. So, where does it go? Where does it exist? In general. Where do you see a graph vertically? Everything greater than 0. Look at your y coordinates in your xy table. Describe the y numbers in your xy table. Where are they? They're greater than 0. Okay. Whatever your range is, it has to describe the numbers in the xy table in the y column. Y is greater, all those numbers have to be greater than 0. The x column, there's nothing to describe them. That's why it says all real numbers. Because you can't say all the x's are greater than 0 or less than 0 or anything like that. There's no limits to the x's because you get to make them up. And then the y-intercept in this case would be 1.